Hello, welcome back. And today we are going to look at the aircraft's instruments. This is the fifth unit of open elective uh, on basics of aeronautical engineering. I am Dr. Ilongovan, professor from the Department of Aerospace Engineering, SNF's College of Technology. This video is intended for the students who are undertaking an open elective from the branches other than aerospace. Let's move on. Now, this is something like we have seen earlier. We have to study the atmosphere. What are the various layers of atmosphere? How are they, distributed? The structure of the atmosphere. First, we have the troposphere from 0 to 12 kilometers, the layer that is closest to the Earth's surface and where the weather phenomena occur. Okay. Next is the stratosphere, that is from the 12 to the 50th kilometer, which contains the ozone layer, which protects us from the harmful solar radiation. Moving on, the next layer is the mesosphere, which is from the 50 to the 85 kilometer range, and then where the temperatures decrease rapidly with altitude. Here, I should like to point out that it doesn't mean that the temperatures definitely fall below as we go up the uh, even in the as we go higher, even in the troposphere. Next is the thermosphere. It is from 85 to 600 kilometers, the layer where the temperature increases with altitude due to the absorption of solar radiation. And finally, we have the ecosphere, the outermost layer where the particles can escape into space. And then, this is where, we send uh, rockets outside the satellites, etc., outside the Earth's atmosphere. The same thing here, the outermost layer has a very low density. The ionosphere in this layer, the northern appear in the northern lights. Its high temperature is around 1500 degrees and destroys the meteorites when they enter the space, enter the Earth's atmosphere. Mesosphere is the coolest layer of the atmosphere, minus 80 degrees. And much nearer when you come down, you have the stratosphere. It contains of the ozone layer, as we said earlier, and protects the Earth from the ultraviolet rays. The troposphere, where the meteorological and the climatic phenomena occurs, and which is very closest to the Earth. The key atmospheric properties are the temperature, pressure, wind, and the moisture. Okay, and we also see here like how it varies with the the temperature varies as you go up uh, the altitude, and how the pressure varies and how the water vapor also varies. Temperature affects the air density, in which in turn affects lift generation. Colder air is denser and provides more lift. Pressure is decreases with altitude. Pilots use pressure readings to determine the altitude and maintain safe separation between aircraft. So pressure, the altitude is indirectly measured using the pressure. Winds affect the flight path, ground speed, and the fuel consumption. Pilots consider with speed and direction when planning and executing a flight. Moisture contributes to the cloud formation, icing, and precipitation. Pilots need to be aware of these hazards to avoid accidents. The atmospheric properties continue because of the molecular movement associated with heat. Heat warm air occupies more space than equal mass of cold air. In other words, warm air is lighter than cold air. Humid air is less dense than dry air because water vapor molecules weigh less than the nitrogen and oxygen molecules they displace. Now here we see that as the atmospheric pressure, how they vary with respect to the warm air and the cold air, and the general barometer pressure that we is being read as a mercury column rises up to 76 centimeters of height. Now, the meteorological data and the flight planning. Pilots rely on the meteorological data to plan their flights. This data includes the surface weather observations or the METAR, en route weather forecasts, TAF, and upper air weather curves, satellite imagery, and the radar data. There's the flight instruments and the navigation instruments. A general picture has been given, like how cluttered they look, and then each one has its own function in front of the pilot. We have the primary flight instruments, which is the artificial horizon or the altitude indicator, shows the aircraft's pitch, roll relative to the horizon. Airspeed indicator measures the aircraft speed through the air. Then altimeter indicates the aircraft's altitude above the mean sea level. Vertical speed indicator um, shows the rate at which the aircraft is climbing or descending. The turn coordinator indicates the rate and direction of a rotation or a turn. Head indicator shows the aircraft's compass reading, where it is lying except there. Additional flight instruments are there. We have something called as the gyroscope, which maintains the artificial horizon stability. Uh, Magnetometer provides the reference for the heading indicator. The engine monitoring system displays the engine parameters such as the temperature, pressure, and the RPM. Traffic Collision Avoidance System, or TCAS, alerts the pilot of potential mid-air collisions as a safety instrument. Then we have the navigation instruments. Navigation instruments help the pilot determine the position and navigate along the planned flight path. And you have the global positioning system, provides the real-time position information using the satellite signals. VOR, the very high frequency omnidirectional range, provides directional guidance to or from the ground station. ILS, instrument landing system, guides the aircraft during the landing in low visibility conditions. ADF, or automatic direction finder, uses the radio signal from a ground station to determine the direction. In conclusion, the flight instruments and navigation instruments work together to ensure the safe and efficient flight. Flight instruments provide real-time data on the aircraft status, while the navigation instruments guide the pilot along their route. Pilots rely on these instruments for crucial decision making throughout their flight, and that the and there we come to the end of this particular video. We have looked at simply what are the various instruments that are available uh, for the pilot, and thank you for joining, and I will post another video in continuation with this in the near future. Okay, thank you very much.